Hey everyone, welcome back to the channel where we dive deep into the cosmos. Today, we're witnessing a monumental event in the universe, the catastrophic explosion of Betelgeuse. Make sure to subscribe and hit the bell so you don't miss any updates on this cosmic phenomenon. Let's get into the details of what's happening and what this means for our night sky. Imagine gazing toward the horizon as dawn breaks, with the sky painted in the radiant hues of sunrise. Recently, ENASA unveiled stunning images capturing a celestial event unlike any witnessed before. A star known as Betelgeuse experienced a dramatic explosion, shedding a massive portion of its surface. This phenomenon, termed surface mass ejection, (SME), involved an ejection that was an astounding 400 billion times the mass of an ordinary solar flare from our own sun. Dubbed by scientists as a real-time view of stellar evolution, this event showcases a star discharging enormous chunks of its material into space. The catastrophic explosion of this super-red giant challenges much of our current understanding of the universe. What triggered Betelgeuse to erupt so violently? What implications might this have on the cosmic landscape? Delving into the mysteries of the cosmos, constellations come to mind. These groups of stars, organized based on mythology and legends, still guide navigators today. Among them is Betelgeuse, a star notable for its size and luminosity in the night sky. Known as Betelgeuse in some circles, this brilliant ruby-red star adorns the upper right shoulder of Orion the Hunter, the famed winter constellation. When observed with care, astronomers can glean more than just light from these celestial bodies. They uncover stories written in the stars. Let's continue this journey of cosmic discovery together. Imagine a celestial giant pulsating through the cosmos with a steady rhythmic heartbeat lasting 400 days. Known for its striking orange-red hue, Betelgeuse is a beacon in the night sky, easily distinguishable and a perfect example to convince skeptics that stars indeed come in various colors. Often referred to as Alpha Orionis, Betelgeuse is the second brightest star in its constellation, overshadowed only by the luminous blue supergiant Rigel. This star is not just a point of light, it's a subject of fascination in astronomical circles due to its variable brightness and the unique characteristics that its odd name implies. Typically, stars named Alpha are the brightest in their constellation. However, despite Rigel's superior brightness, Betelgeuse holds the title, perhaps due to its striking presence and size. Betelgeuse's fame extends beyond astronomy. It inspired both the character and the title of the movie Betelgeuse. As the seventh brightest star visible from much of North America, Europe, and Canada, and the 10th overall in the night sky, its allure is undeniable. Positioned relatively close to Earth, astronomers estimate its distance to be between 430 and 724 light-years away, making it the nearest bright red supergiant in our galaxy. Among the vast expanse of the cosmos, only 200 red supergiant stars have been cataloged, and among these celestial giants, Betelgeuse stands out. If this colossal star were to replace our Sun, its immense size would stretch beyond the asteroid belt, engulfing not just Earth, but also Mars, Venus, and Mercury in its fiery embrace. Betelgeuse's radius is approximately 764 times greater than that of our Sun, illustrating its staggering scale. Weighing in at 16,112 times the mass of the Sun, Betelgeuse shines with the intensity of 126,000 suns. Despite being 548 light-years away, it remains a beacon in the night sky due to its extraordinary luminosity. With a cooler surface temperature of 3,600 Kelvin, much lower than the Sun's, only about 13.3% of Betelgeuse's radiant energy manifests as visible light. Yet, if human eyes could perceive all wavelengths of light, Betelgeuse would outshine Sirius, currently known as the brightest star visible from Earth. Betelgeuse is not just massive, but also dynamically active, shedding about one solar mass every 10,000 years. It is enshrouded by a nebula formed from material ejected unevenly in all directions, creating a cloud 250 times its size. This nebula spans about 30 astronomical units, equivalent to the distance between the Sun and Neptune, marking the outer boundary of our solar system. This sprawling celestial phenomenon underscores the vastness and the volatile nature of Betelgeuse in the universal tapestry. In our solar system, the Sun regularly sends massive amounts of material into space, known as solar flares. More specifically, it exhales tiny fragments of its outer atmosphere, the corona, in events called coronal mass ejections, chimeras. These chemes can happen independently of surface mass ejections, which involve the expulsion of larger portions of a star's outer atmosphere. Chemes are a frequent occurrence in our solar system and carry both magnetic fields and plasma as they travel at speeds exceeding 1,800 kilometers per second. When these charged particles reach Earth, they can wreak havoc on satellites and power infrastructures, posing risks to astronauts in orbit as well. This is particularly concerning when a CME occurs on the side of the Sun facing Earth. The intrigue deepens with the recent observations of Betelgeuse, a star known for its steady pulsing pattern, which underwent significant changes in 2019. The dimming observed from Earth was traced back to an exceptional CME event on Betelgeuse. The material expelled by this star exploded into space, cooled, and formed a cloud of cosmic dust, effectively cloaking the star's usual brilliance from Earth-bound telescopes. This unusual CME on Betelgeuse not only highlights the dynamic and sometimes unpredictable nature of star behavior, but also underscores the vast impact these celestial events can have, echoing across light years to reach observers far away on Earth. In a dramatic turn of celestial events, Betelgeuse released a mass 400 billion times greater than a typical coronal mass ejection, CME causing the star to quiver like a trembling dish of gelatin, as described in a NASA news release. André Dupree, from the Center for Astrophysics, speculates that the star's internal convection cells are in turmoil, while the photosphere, the visible surface of the star, struggles to reconstitute itself. For 2 centuries, astronomers have monitored Betelgeuse's consistent patterns, which have now abruptly ceased. This transformation is not just a spectacle, but a critical window into the life cycle of red giants like Betelgeuse, which are in the twilight of their cosmic journey. Observing these changes offers invaluable insights into stellar evolution. The life of a star is fueled by nuclear fusion, a process where hydrogen atoms, under immense gravitational pressure, fuse to form helium, releasing vast amounts of heat and light. This energy travels through the star and is emitted into space as photons. As a star ages, its primary fuel hydrogen depletes, initiating a sequence of fascinating stellar transformations leading up to its eventual demise. The opportunity to witness these changes firsthand provides astronomers with a deeper understanding of the forces shaping our universe. As stars like Betelgeuse evolve, they undergo dramatic transformations in their core. After exhausting its helium, the star begins to fuse helium with carbon, forming denser elements. This process continues until neon combines with carbon to form iron, marking a critical shift. Unlike earlier reactions that release energy, the fusion of neon into iron absorbs energy, leaving nothing to counteract the star's immense gravity. Once iron fusion starts, the star is doomed to collapse under its own weight, leading to a cataclysmic supernova explosion. Supernovas are among the most powerful events in the universe, unleashing more energy than 10 billion suns combined. Throughout their lives, stars change colors from the hot, young blue stages to the cooler, mature red phases reflecting their evolutionary stages. Historical observations reflect this. The Greek scholar from 168 AD described Betelgeuse's color as ruddy, while 3 centuries earlier, Chinese astronomers noted it as yellow, suggesting it was once a yellow supergiant. Larger stars like Betelgeuse burn through their hydrogen quickly, leading to a shorter lifespan. Despite being only about 10 million years old, Betelgeuse is already approaching the end of its life. In contrast, Our Sun, at about 5 billion years old, is still in the prime of its life. As Betelgeuse nears its final stages, its dramatic end serves as a profound reminder of the dynamic and transient nature of stellar life cycles. As Betelgeuse approaches the twilight of its existence, the possibility of a looming supernova grows ever more imminent. This enigmatic star exhibits a unique pattern of dimming and brightening cycles, the second of which recurs roughly every 5 years, lasting about 100 days. During these cycles, it's believed that the star's outer shell expands and contracts, altering its circumference and average temperature with each phase. These fluctuations provide astronomers with invaluable clues about how red stars shed mass in their final moments before they culminate in a dazzling supernova explosion. From observing Betelgeuse's recent activities, astronomers have witnessed a massive ejection of surface mass, an event previously unseen and not fully understood. This phenomenon offers a direct window into stellar evolution, unfolding in real time. Equipped with tools like the Hubble Space Telescope, researchers can observe these changes up close and decode the mysteries of stellar surfaces. However, it remains uncertain whether these dramatic events signal the imminent explosion of Betelgeuse into a supernova. While the developments are unusual and have prompted caution from NASA, it's noted that cosmic timelines are extensive, and even as Betelgeuse nears its end, the actual moment of its demise could still be a distant future event. According to NASA, Betelgeuse could still take another 100,000 years to finally erupt in a supernova, underscoring the vast and unpredictable scales at which cosmic events unfold. Since as far back as the 1st century BC, the star Betelgeuse has captivated astronomers. But it was not until recently that Serafina Nance and her team embarked on a mission to unravel the mysteries of red supergiants like Betelgeuse. Their goal was to predict the timing of potential supernova explosions and to understand how such colossal stars behave over time. Using Betelgeuse as a template, Nance's team conducted multiple simulations and juxtaposed their results with real-time astronomical observations to probe deeper into the star's life cycle. Intriguingly, Betelgeuse experienced a sudden and uncharacteristic dimming, deviating from its typical brightness cycle, a phenomenon that left astronomers puzzled, especially considering predictions that it wouldn't likely explode for another 100,000 years. This anomalous behavior was noted after Betelgeuse was displaced from its original cluster in the Orion OB1 Association, home to the well-known stars of Orion's belt. Now, a rogue star, it carves its path through the interstellar medium at a remarkable speed, generating a bow shock as it disrupts the cosmic environment. By mid-February 2020, this celestial wanderer had notably diminished in luminosity, plummeting from a magnitude of 0.5 to 1.7 since its sharp decline that began in October 2019. However, by February 17, 2020, Betelgeuse's brightness plateaued for nearly 10 days before it began to increase once again. Just 5 days later, the dimming ceased entirely, marking a dramatic pause in its fluctuating brightness and leaving astronomers watching and wondering about its next celestial act. The mysterious dimming episode of Betelgeuse came to a close without any significant changes detected in the infrared spectrum by February 24, 2020. This peculiar visual fading seemed to disconnect from the catastrophic scenarios often anticipated with core collapses. Instead, a study carried out on the same day suggested that the dimming was most likely due to a cloud of large-grain circumstellar dust. Although earlier research using submillimeter wavelength measurements had dismissed dust absorption as a significant factor, the prevailing theory shifted towards large star spots as the primary cause of the dimming. Further scrutiny revealed a dramatic increase in Betelgeuse's brightness between May and August. Positioned so near to the Sun, Betelgeuse typically remains almost invisible from Earth until 2020, when it was expected to align with the Sun, registering a brilliance of plus 0.4. However, observations from the EST-EREO-A satellite during June and July 2020, recorded an unexpected fading to 0.5 from its previous observation in April. This surprising development confounded astronomers, especially since the maximum brightness and subsequent minimum were anticipated around August-September 2020 and April 2021, respectively. Betelgeuse's propensity for dramatic fluctuations in brightness has historically made it a challenging subject for accurate predictions. The unexpected fading observed suggested the potential onset of a second, equally unpredictable phase of dimming, further complicating the celestial narrative of this enigmatic star. The discovery of a second dimming event involving Betelgeuse suggested that it might occur much sooner than initially anticipated. In June 2020, scientists proposed that a newly detected dust cloud emanating from the star could be attributed to a cool patch on its photosphere, which may have triggered the dust formation. By August, a second independent investigation supported this initial hypothesis, solidifying the notion that this dust resulted from gas expelled by the star. Further studies conducted in 2022 with the Hubble Space Telescope revealed that the dust cloud likely originated from a surface mass ejection. This violent expulsion sent material from the star's surface millions of kilometers into space, where it cooled, compacted, and ultimately formed a dust cloud. This cloud, heavy with material several times the mass of our moon, veiled the star from Earth's observers, causing the noticeable fading that began in late 2019 and was visible for several months thereafter. Even amateur astronomers, from the comfort of their backyards, could observe the significant changes in the star's brightness. What's more, the historical 400-day pulsation rate that characterized this supergiant has not been observed since around 200 years ago, marking a significant shift in the behavior of this enigmatic star, as tracked by astronomers over centuries. By analyzing the surface motions and brightness variations of Betelgeuse, astronomers have gained insights into the magnitude of its recent disruptions. They've developed a theory to explain these phenomena. The star is not only recovering, but also regenerating its photosphere, albeit with its normal cycle significantly disrupted. The internal structure of Betelgeuse is resonating like a bell that has been struck hard, a clear indicator of massive stellar upheaval. This sort of stellar surface mass ejection has never been observed before, presenting a mystery that even now remains only partly understood. However, with the Hubble telescope, astronomers have the unprecedented opportunity to observe this new phenomenon up close and monitor the star's evolution in real time. As for when Betelgeuse might go supernova, the timing remains uncertain. It could happen tomorrow, or it might not occur for another million years. Regardless, the supernova explosion of Betelgeuse poses no threat to Earth. To impact life on our planet significantly, a supernova would need to occur within 50 light-years, but Betelgeuse is well over 500 light-years away. Instead of concern, this cosmic event offers a universal spectacle. When Betelgeuse finally does explode, it will provide a stunning show visible to everyone on Earth, at once an awe-inspiring reminder of the grand scale and beauty of our universe. Prepare to be dazzled by a celestial spectacle. Should Betelgeuse ever go supernova, everyone on Earth will be treated to the sight of an extraordinarily bright star lighting up the night sky. Despite its proximity, Betelgeuse is currently not visible in the night sky, so you won't spot it there even if it were to supernova right this moment. It would be obscured by the midday sun in August. Intriguingly, Betelgeuse might have already exploded into a supernova anywhere from 5 to 29 years ago, and we are just waiting to catch up with the light from this epic event. Scientists are particularly thrilled at the prospect of witnessing Betelgeuse's monumental eruption and subsequent recovery. In the meantime, NASA's James Webb Space Telescope stands ready to track any material ejected by Betelgeuse as it journeys across the cosmos. Simultaneously, the Hubble telescope continues its vigilant study of the star. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blisovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blisovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.